Hello, yun. Good afternoon. My name is Dan Allen Romero, and I will be discussing with you today our assignment regarding the SAP-1 simulation. This is including all the content or the instructions that will be executed during the SAP-1 architecture. So, yeah, let's go. Um, First, this is the given memory address and instructions, and this is the SAP1 architecture. So basically, before I go to this simulation, I want to get the exact overview of this simulation based on what are the instructions given on this assignment. Yeah. So first, I need to analyze the instructions. So step one ng kung anong ginawa ko, I need to check and analyze what are the instruction on that given address and given opcodes, okay? So I put here the memory and the actual cycle execution. So based on this address or the opcode plus the instructions, I added the interpreted data and the exact binary value for this process. Okay. So, as you can see, the instructions, 5 instructions is there. And then also the RAM value could be seen in this 6 to 11 index. Yeah. So I did the same. The RAM value is can be seen here. The address, which is the exactly the same data with this one, and then the exact the same data with this given instruction set. Yeah. So, okay. So, as we zoom out this one, so I will be discussing what I did in the step one. So, step one is that we have this 5 executable instruction. Yeah. So, if you try to interpret the data, first we need to say or we need to have the instruction LDA 11. So, this means load data from RAM address 1011. Yeah. So the exact binary value is this 000 1011. So this 000, by the way, is based on this SAP instruction set. Okay. So we have this load 000, add, sub, out, and halt. Yeah. And this is their corresponding opcode. So in this case, I'll be uh, having the next set of instruction based on the given instruction set. So next would be the add data from the address RAM. RAM address 1001. Okay, so the exact binary value is this uh, sum or the add, and then the exact address 1001, which is 10. So by the way, LDA 11 here is a binary, so we need to construct it into a hex data. Okay, same as the 10 here. So this would be also in decimal, so we need to put it into hex. So the next instruction would be to subtract decimal value 7, which is the 0111. So in the interpretation of binary value, it's the last operation for this, which is subtract. Uh, and subtract opcode would be 0010, and then the exact address, which is 0111. Yeah. And then the last two executable instruction is the display and then the end of this execution. So basically, we will be just adding loading what's in the data, or the loading the data from this address, adding the data base from this address and then this address, and then subtract whatever the value of the accumulator, and display this and then execute. Okay, so as you can see, we have the step 2, we have the RAM data, which is here. And then in the step 3, I will try to show to you or explain to you what happened during this execution. So looking at the instruction set, we have the 1011, 1001, and 011 addresses. So if we try to check and load the data in the RAM, it would be the 7, 9, and 10 addresses. So if we try to understand and evaluate the execution of the controller, which is in the our architecture is this one, this controller, this would be exactly the same as what we have in step 1 to 5. Okay, so if we say, let's say LDA, load address RAM data, so the we will gonna be loading the data from 1011, which is this one, and the data for that, the address is 7, so we need to um, load the data or this address 1011, and then we try to add that data 1001. So currently what we fetch in the address data 1001 is 5, so we need to add both, and the total of that would be going to the accumulator, which is 12. And then if we try to simplify this, we need to have exact value from the total, which is 12, and then let's subtract the data from the address 011, which is this one. Okay, so it would be 3. So 12 minus 3 would be 9, and exactly the output would be 9. And that's the end of our instruction set. Yeah. So this time, since you know the overview already of what should be the instruction would perform, or how the instruction should perform, let's now discuss how it was be simulated inside the architecture, or the SAP-1 architecture. Okay, so um, let me just zoom out a bit. So as you can see here, we have the timer T1, and of course, uh, all of our architecture will start from the program counter. Okay, so I'll try to explain to you how these instructions would be simulated inside this SAP1 architecture. Okay, so as you can see, when we have the current instruction set, and our simulation would start always with the program counter. Okay, so T1. So in the program counter, we can see that during T1 of our simulation, the EP pins and this LM pins is enabled. Yeah. So during this time, our program counter would be hex value 1. Okay. And then, of course, this would be sent to the bus. And when this program counter is already in the bus, um, automatically the pin of the MAR, or the memory address register, is active. Okay, and in this time, MAR would be looking on the specific instruction set that is loaded into the architecture. So in this case, as we have discussed, right, the binary value would be 0001011. Okay, so that would be the data of MAR, and then the MAR would communicate it to the RAM. Of course, we need to have the RAM address 1011. We need to look at it. So as you can see, the instruction set from the higher enable is the 000, which is the load instruction set. And then we need to check the address of 1011, wherein if we try to interpret this, is to load the data from address 1011 of the RAM. Okay, so when MAR communicated, the MAR block tried to communicate it with the RAM, the CE would be enabled, and then the RAM would have this data to be fetched by the instruction register. Okay, so the instruction register now would understand that, okay, we have the specific command that we need to have this load data from the RAM address 1011. Okay, now when the IR outputted it, the controller register will also be manipulating the data, getting the high uh, nibble and the lower nibble to be to be executed, sorry, or to be analyzed by the controller. So as you can see here, the first data would be to load the data and um, get the value from the RAM 1011, which is this time is 7. So what we're gonna do here is that during this state, the program counter would be, sorry, T3. And if we try to understand during this time, the T2 part would be the next program counter, which is in this case 1. Okay. So during T2, sorry, we have the next set of data or set of instruction to be performed. But in T3, we now have the actual value of this first instruction, which is the 10 load data from 1011. Okay. So this would be the uh, this value. I mean this value of 1011 will be now loaded into the accumulator, and we will gonna be executing the next um, how to say next set of instructions, which is add. Yeah. So in add, the same way, when we have the program counter incremented, this time if we look on our binary value, it should be this one, right? 001 1001. So if we try to simulate it, the mar would become 001 1001. And then the same way, we will be needing to get the data from our RAM 1001, and then the instruction register again will try to interpret this data, which is in this block it become addition, and then in the controller register it would gonna be interpreting as a new instruction set, which is addition, which is 001 opcode, and then of the address register 1001. Okay, so in this case we have the 1001 data, and this 1001 data would go to the mar again, and then the mar will gonna fetch the exact data from the RAM, and it would be going to the register B. Yeah. So currently, from our execution, we already have this 7 plus 5, which is the value of 1001, which is 5 execution um, from our architecture. Yeah. And then eventually, what would be the after we have the adder and subtractor. So here we just perform adding of one address 1001 and 1011 1011. Yeah. Okay. So basically the interpreted data for that is 7 plus 5. So whatever the value of that, let's say the value of this data now is 12 in the accumulator. In the next program counter, we will be gonna having the 3. Okay, so 3 is 0011. In this case, we will be needing to subtract naman the value, the specific value from the RAM. From the accumulator. So currently, our next set of instruction will be subtract, and subtract will be 0010 okay, 0010 and 0111. Okay, as you can see here. And of course, the same way the counter will tick, since we have the program counter already tick. And then the MAR will also evaluate the, store the actual instruction set, and then fetch the data from the RAM, which is right now, we will be dealing with the address 0111. So in 0111, as you can see here, the data would be 3. Yeah. So in this case, we will be fetching the data, and then we will try to give this specific set of instruction to the instruction register. So instruction register would possess the data, which is 3, and then give it to the controller. While it gives to the controller, it will also give back the 1111 data to the MAR, and MAR will also give that data into the register B. Okay, so in this actual scenario, we have the controller next instruction, which is the 0010, and this controller instruction would be subtract. So now what would happen is, we will gonna be subtracting what is the on which would be the value of the register B. So currently we have the this both instruction set, but now we will be gonna um, executing what is in the register B, which is subtracting the uh, current data from accumulator, which is 12. Yeah. So as you can see here, um, the register B now would possess the data, which is 3, because of the executed here by the RAM and IR and the controller. Yeah. So what will happen is that we will be gonna executing this third step here, the subtract data from 011, which is 12 minus 3. So now the exact value of our accumulator would be 9. So in that case, we will be executing the next instruction, which is output, and we will be gonna having the next program counter. So this would be 0100, and then of course the T1, T2, T3 will be incrementing the same way as what we have in the SAP-1 architecture. But then we need after this we will be executing the output, which is the command would be 1110. Yeah. So when we try to put it in MAR will try to understand um, what is the next set of instruction. Yeah. So MAR will, since there is no specific uh, what this one again, the output is 1110, sorry, so 1110. So since there is no specific uh, RAM to be read, memory address to be read, this would the data for MAR would be directly coming to the uh, RAM, but the RAM will just execute it and be reading the NOP, no operation. So the next would be the instruction register to decode the 1110. So when the controller see that, okay, 1110 is output, so it will just gonna send this command out to the bus, and then of course it would be the uh, going to the um, OP display. So now the AC accumulator display would output this 9, and it would be the uh, data, which is 9, and then it would gonna be directly communicating to the display. Yeah. And then the last part would be the uh, uh, program counter 5. Again, we're gonna have this program counter incrementing, and the MAR will just execute the last instruction, which is the 11111, or the halt, and then we will gonna have this data 11111. Same way, it the RAM have no specific address to be looked for. I mean, the MAR have no specific address to look in the RAM, so it will just be passing out here, and the IR would specifically decode the message and then give it again to the controller. Now the controller would see that okay, this is now to halt, so the halt will be happening, and it will gonna exit the program. So that would be the last execution, and then it would output the final program as 9. So yeah, I hope you learn about this, and this would be the uh, summary and the overview of this. So hope we can have the next video. Thanks and goodbye.